So this is our next example, example number 2, still under the application of the equation of linear motion. So the question is saying that a car is being driven along a road at a steady speed. Is that okay? So that means that they have given you the speed u as a 25 meters per second. And then when the driver suddenly noticed that there is a tree, there is a fallen tree blocking the road 65 meters ahead, isn't it? At a distance of 65 meters, the driver realized that there is a tree which has blocked the road, he can't even pass. Okay? And then suddenly applies the brake, giving the car a constant retardation of, that means that the car was now decelerating, isn't it? So negative 5 meters per second, okay? Because it is a deceleration, a negative acceleration. So now the question is, how far in front of the tree does the car come to? So when he started applying the brake to reduce on the speed, and then if he finally comes to rest, how far in front of the tree did he come to rest? So if I can make my simple sketch here, I would maybe say I have this car here, some simple sketch to elaborate what we're exactly talking about. If this is my car, it is traveling along the road, and I have my fallen tree here that is blocking the road. This is my fallen, just like a simple sketch. And now this driver here noticed when it was 65 meters that this car, that this tree was blocking the road. He was here and now started applying a brake to come at rest. Supposing maybe if this is point A and then this is point B, supposing he came to rest at this point here. Now the interest is how far in front of the tree, what is this distance x? Supposing he came to rest at this point here, he started reducing the speed right away from here, reducing it, and now finally the car stopped here. He was almost knocking it. Some distance was remaining. What is that exact distance that is remaining for him to knock the tree is what they are interested in. Is that okay? And now from here, we can first decide to calculate the distance covered in this retardation. Which equation are we going to use? So we shall say using v squared equaling to u squared plus what? Plus 2as. Is that okay? Plus 2as. So initially the speed here was this, but he started reducing the speed. When he finally comes to rest, the speed will be 0. So that means that I can say 0 squared equaling to u, the initial speed was moving with, that is 25 squared, plus 2 into acceleration is a negative one because it was retarding. The speed was reducing, that means that is a negative acceleration. So I can say negative 5, and now times the distance he covered while breaking down. Okay? Times that distance here that I can say from here it is s. That if you started reducing the speed here and it stopped here, what is the distance covered while breaking down? While breaking the speed or reducing on the speed. Now, from here, this is our s, please. From here, I can now say this is the same as, this is minus 10. I can take it to say now, this is 10s equaling to 25 squared. So you divide both sides by 10, divide both sides by 10. 25 divide by 10. Actually, 25 squared divided by 10. That is 62.5. Okay? Let me hope you're also getting that. S equaling to 62.5 meters. Is that okay? So that means that in the process of breaking down, this guy here traveled a distance of 62.5 and now he ended here. Okay? Now, what is the remaining distance? The remaining distance is from here up to here, subtract that. The remaining distance x is 65, is x equaling to 65 minus 62.5, and that will give you 2.5. So the car stopped 2.5 in front of the tree. Therefore, the car stopped 2.5 meters in front of the tree. Or the car came to rest, isn't it? The car came to rest 2.5 meters in front of the tree. All the same. So that is for the first part where they're asking us that when he was reducing the speed, how far in front of the tree did that guy actually come to rest? So it is, we can work it out following this procedure here. And then let's look at what can we now do with the second part. That if the driver had not reacted immediately and the brakes were applied 1 second later, with what speed would the car have hit that? That supposing the driver delayed in applying the brake, isn't it? Supposing the driver delayed in applying the brake, with what speed do you think he would have hit the tree? So now the question is, the point is, if he's delaying in applying the brake for 1 second, that means that when he saw it 65 meters and he delayed for 1 second, that means he had reduced part of the 65 meters, isn't it? He would have covered part of it in 1 second. So let's look at, for the 1 second, wow, what is the distance covered out of the 65? Because he did not apply immediately in the distance of 65. He first traveled 1 second. So for part B, we can look at distance covered in 1 second. I'll say using S equaling to UT plus a half AT squared. If I'm looking at that, I'm looking at the distance covered in that time frame. So I'll say SC, it was moving with a constant velocity. So I can now say I have my U. What is my U in this case here? If we are looking at the distance covered in 1 second, I'll say S equaling to, this work, S equaling to U, which is now my 25 times 1 plus, it was moving now with a constant velocity, therefore acceleration is 0, a half into 0, 1 squared. I don't know if people are following that. That if the body is moving with a steady speed, what is very true is that we said acceleration is 0. So that means that as it was moving with 25, it saw the tree 65 meters ahead, but he did not apply the brake immediately. He delayed by 1 second. Now, in that 1 second, what is the distance covered? And then he started applying a brake. So if we are using this formula here, acceleration will be 0 because he was still continuing with the 25, which was a steady speed. And you said if the speed is steady, constant, uniform, we shall say acceleration is 0. So that means that the distance covered is equivalent to now 25 meters. So now he covered 25 meters in 1 second. So what is the remaining distance is what we should now look at. conclude that if he's now to apply brake after 1 second, he will apply brake in remaining distance. 25 would have been removed. So we can now say remaining distance for applying brake is the 65 subtract now away 25, because 25 meters has been captured in the process of delaying to apply the brake. So that means that we shall have here our 40. Is that okay? You can try there, pick your calculator and then try to press and see what is 65 minus 25. So that means this guy applied brake in a distance of 40. Now, how do we now calculate with which speed did he, with what speed would the car have hit the tree if he had delayed? So we want the final velocity of hitting the tree. So we can also say now using v squared equal to u squared plus 2s. Is that okay? We are interested in finding the final velocity of hitting now, because now after this he's going to start applying brake, and therefore the speed will no longer be a constant one, because he's now applying the brake to reduce on the speed or to change the speed. Now, what is that final velocity that we need? Initial speed there will be to our 25 squared plus 2 into, it will be reducing speed at the rate of for that, and now the remaining distance for applying the brake will be 40. So our v squared here, you can now comfortably pick your calculator and then press. That is 25 squared minus this is 10, and now that is 400, isn't it? Yeah. And then you press that, you get 25. This will give you 2 to 5, which is 15. So this is 2 to 5, and then get root both sides. If you take root, you will get 15 meters per second. Therefore, you conclude and say the car would have hit the tree with a speed of, so you say the car would have hit the tree with a speed of 15 meters per second. That is the speed with which it would have hit the tree. Thank you.